Good morning, students. This is Ms. Volcano, and today I wanted to go through this worksheet on atomic number and atomic mass and kind of give you guys a bunch of examples that will help you go through the rest of it. So the learning target for this worksheet is that you will be able to use the atomic number and atomic mass of an element in order to determine the number of subatomic particles present in the element. Okay, so what does that all mean? Going to our periodic table, you will find all of the elements in the universe present on the periodic table. And you can see that for every element, you can basically see two numbers listed on here. And they're showing you, they're taking out hydrogen and kind of showing it to you as an example. But you will see a number at the top, which is the atomic number, and you'll see a number at the bottom, which is the atomic mass. We're going to talk a little bit more about that. But if we go back to your worksheet, you can see right here, it's asking you for the different elements for the atomic number and atomic mass would go under this column. So let's see how we can use these two numbers from our periodic table in order to determine protons, neutrons, and electrons. These are some subatomic particles present in each element, and let's see how we can determine them. So I'm going to go on my Jamboard, and let's do the first example. So first example is chemical symbol H. So what I'm going to do is I'm going to go to my periodic table, and you will have access to this for your assignment and for the rest of the class. So I'm going to go and look for H, hydrogen, and it is right here on the periodic table. And what I'm going to do for myself, I'm actually going to, just to kind of show you guys, oops, okay, my snipping tool is not working, but that's okay. What I wanted to copy and paste it on my Jamboard, but I don't have to do that. So you can see that for hydrogen, you can see that it has 1, and then it has 1.008 down here. So from my periodic table, we're basically saying that hydrogen looks something like this. On the periodic table, you see the symbol H with a 1 and 1.008. And we said before that 1 always gives us the atomic mass. I'm sorry, 1 is the atomic number. Sorry for that. So 1 is the atomic number for this element. So what does atomic number mean? Atomic number means the number of protons present in that element. So I can list right here, atomic number is 1 for my periodic table, and I immediately know that whatever the atomic number is, that is going to give me my number of protons. So my number of protons is 1. Another thing that I know from the atomic number, all elements on the periodic table are neutral elements, meaning that their number, so for a neutral element, it means that the number of positive charges that they have, or protons, is equal to the number of negative charges that they have, or electrons. So unless I am told some other information, unless I am told that this element is not neutral, I will assume that it is neutral, which means that I will know that whatever number of protons I have, that is also the number of electrons it has. So for my hydrogen, which I'm going to write the name of right here, so this is hydrogen. For my hydrogen, the atomic number 1 told me that I must have 1 proton, which tells me that I also have 1 electron. What else can I find out from the periodic table, from the information off of the periodic table right here? Well, the other thing I can find out is this number at the bottom, which, as you can see on the periodic table, it is known as the atomic mass of that element. So I will write that, and let me change color. So this is the atomic mass. So I can go and fill in this column right here. So the column is telling me rounded atomic mass. You will notice that the atomic mass has decimal places. What I'm going to do is round that to the closest whole number. So in this case, the closest whole number to 1.008 would be just simply 1. All right? So my rounded atomic mass is 1. Number of neutrons, how do I find that? Well, what I know is that the atomic mass is equal to the number of protons plus the number of neutrons. Neutrons, they have a little 0 here, which means that they are neutral. They don't have a charge. They're not positive or negative. They're just neutral. So let me see for this, what do I know? Atomic mass for hydrogen, we just said it's 1. Do I know the number of protons? Yes, we just found it before. Number of protons is 1. I know that because of the atomic number. And number of neutrons is what I must find. Number of neutrons, 1 minus 1 is going to be equal to 0 in this case. All right? So the number of neutrons, if you want to write it this way, is always going to be equal to your atomic mass minus the number of protons. That's how you can find your number of neutrons. You can use this little equation for yourself. All right, let's do the next one. Let's go a little bit faster through this one now that we set it up. So let's do helium. So the first thing I do, I'm going to go and find helium on the periodic table. And helium is right here. It has 2 for atomic number and 4.00260 for atomic mass. So let me write that down for myself. So I got helium. We said the atomic number off of the periodic table is 2. And the atomic mass is 4.00260. So let me write that down. And I am gonna round that to the closest whole number, which is just going to be simply 4. All right. Well, now that I know the atomic number, I know that the atomic number automatically tells me the number of protons in that element. So number of protons must be the same as my atomic number. They must be 2. That also will tell me the number of electrons in my element. So I also have number of electrons 2. Because this is a neutral element, meaning that protons and number of electrons must be equal. So now I'm just left with this column where I have to find my number of neutrons. Well, number of neutrons, I know that neutrons is equal to just simply atomic mass minus the number of protons. So I can write myself that little equation right here so I can easily find it. So number atomic mass in this case is 4. Number of protons is 2. 4 minus 2 equals 2. Let's go and do the next one, iodine. Again, I'm going to go to my periodic table. I'm going to look for iodine. How do I know it's iodine? Because I can see the symbol I. So if you don't know it's iodine, I'm not expecting that you guys already know that. What you would do is go to the periodic table and look for the letter I, capital letter I. I can find that right here. I, it stands for iodine. It has an atomic number of 53, so I'm going to go and write that. So I got iodine, atomic number of 53. And my rounded atomic mass for iodine, 126.90. I'm going to round that to 127 because that is the closest whole number. So 127, I'm going to write that down under my atomic mass, 127. All right, how about the number of protons? Well, number of protons must be always the same as the atomic number, so I got to have 53 protons, which means that I also must have 53 electrons because this is a neutral atom, meaning the negative charges must be exactly the same in order to balance the positive charges. Finally, the number of neutrons. All I have to do is take my rounded atomic mass, 127, minus my number of protons, 53, and 74 is my final number. Okay, so that is how you solve this kind of problem. Let's go down over here and see if there's anything. So this is basically the exact same thing, but given to you in a little bit of a different format. So let's talk, for instance, about this one here, which gives you a little bit, the information a little bit backwards. So it's giving us information about the atomic number, which we know it must be also the same number of protons, same number of electrons. So how do I even find out what chemical name and chemical symbol do I have for this? Well, the atomic number tells me. The atomic number is like the fingerprint of an element. When you think about a fingerprint, every human being has a unique fingerprint. Nobody else has a fingerprint like that human being. So the atomic number for an element is the same thing. No two elements have the atomic number. If we know the atomic number of an element, then we automatically know what that element is. So let me go and look for atomic number 86 on my periodic table. And if you notice, the atomic numbers at the top, they go in order. So 86 is right here. 86, Rn is the chemical symbol. Radon is the name of that element. So I'm going to put chemical symbol Rn, and that should not be capital N, that should be lowercase, and chemical name radon. And from there, I can find my atomic mass. Atomic mass for radon is given to me right here, 222. I'm going to round that to 222, so I can put that atomic mass 222 right here. Number of neutrons, all I would have to do is take 222, my atomic mass, minus 86, and do that subtraction, and I'm gonna get 136 for that. 222 minus 86 is 136 neutrons. All right, good luck with the rest of the assignment, and I will see you guys